Volumetric apparatus. Volumetric apparatus is an essential requirement for quantitative estimations. Different types of glassware are used in quantitative chemistry to measure the volume of liquids. The reason why only glass equipment is used in chemistry is due to their negligible reactivity, high durability, and lesser cost. However, one needs to use these equipments carefully to get appropriate readings each time. Along with this, a regular calibration of volumetric glassware is also compulsory to achieve more accurate results. Accuracy is the most crucial factor in quantitative chemistry. A slight error in measurements can lead to a great disaster. That is why only standard volumetric glassware is used in the domain. But these apparatuses also fail to deliver the exact estimations even after claiming to do so. This is where the calibration process comes in. It is utilized to check how precisely can the equipment measure a volume. So, during any experiment, the corresponding apparatus's error can be taken into account. Laboratory glassware is made from borosilicate glassware, which is resistant to thermal shock and chemical attack. Volumetric glassware must be washed and dried before use, as unclean glassware can introduce contamination errors. So, let's have a look at them.
Test tube is also known as a sample tube is a common piece of laboratory glassware used for conducting various tests by taking small amount of reagents. Test tubes of different dimensions are available. Test tubes with smaller dimensions are known as semi-micro test tubes. They are kept on test tube stands. Funnel. Laboratory funnels are used to channel liquids or fine-grained chemicals into labware with a narrow neck or opening. They are made of plastic or glass. There are different kinds of funnels that have been adapted for specialized application in the laboratory. Wash bottle. It is a water container and used for transferring water during volumetric analysis, making up of solutions, washing precipitates, etc. It is made up of glass or plastic and available in different dimensions. A glass rod is a piece of laboratory equipment used to mix chemicals and liquids for laboratory purpose. They are usually made of solid glass, about the thickness and slightly longer than a drinking straw with rounded ends.
Erlenmeyer flask. An Erlenmeyer flask is also known as a conical flask or titration flask. It is a type of laboratory flask which features a flat bottom, a conical body, and a cylindrical neck. It is named after the German chemist Emil Erlenmeyer, who created it in 1860. It is used in volumetric analysis for carrying out titration. The flat bottom avoids the risk of liquid going up to the sides due to the whirling motion during titrations. It is available in different dimensions of 50 ml, 125 ml, 500 ml, etc. Depending on the application, they may be constructed from glass or plastic in a wide range of volumes. Measuring cylinder. A graduated cylinder, also known as a measuring cylinder or mixing cylinder, is a common piece of laboratory equipment used to measure the volume of a liquid. It has a narrow cylindrical shape. Each marked line on the graduated cylinder represents the amount of liquid that has been measured. Graduated cylinders are more precise than laboratory flasks and beakers. Measuring cylinders are also available in different sizes. They can be of 10 ml, 20 ml, 100 ml, etc.
Standard flask and standard flask is also known as measuring flask, volumetric flask or graduated flask. Standard flask is a type of laboratory flask calibrated to contain a precise volume at a certain temperature. The standard flask is a long narrow necked flask with a tight fitting glass stopper. The neck of the volumetric flask is elongated, a narrow with an etched ring graduation mark. The marking indicates the volume of liquid contained when filled up to that point. Standard flask of various capacities such as 50 ml, 100 ml, 250 ml, etc. Volumetric flasks are used for precise dilution and preparation of standard solution.
Pipette. Pipette is an important apparatus used in volumetric analysis. Pipette is used to deliver a definite quantity of liquid in quantitative analysis. It consists of a long glass tube with a bulb in the middle and the lower portion of the tube ending in a jet or nozzle. The capacity of the pipette is marked on the bulb. We can transfer only one volume by an ordinary pipette. Graduated pipettes are used for transferring different volumes. Pipettes are of various volumes 100 ml, 50 ml, 25 ml, 20 ml, etc. How to use pipette by mouth. With a method that carefully mimics the sucking of a straw, draw a solution upwards through your pipette to your desired volume by suction, which create a tension by reducing air pressure inside the pipette. Maintain the tension with your mouth. Immediately put your left index finger over the top of the pipette and hold the level of the solution until you transfer the solution to a conical flask. Mouth pipetting is forbidden now, especially by using concentrated solution. This is the most common method of becoming infected or poisoned in a chemical laboratory. So, rubber bulbs are used nowadays. It serves as a vacuum source for filling solution through a pipette.
Buret. Burets are typically used for titrations and are used for dispense small volumes of liquid or sometimes gas with high accuracy. It consists of a long narrow graduated glass tube and you can see the graduation marks on it. Looking at the top of the burette, you will notice the first graduation is 0. But as you move down, the volume increases. So the volume of liquid in the burette is read from top to bottom. At the bottom of the burette, there is a stopcock which allows you to regulate the flow of liquid. And the tip of the burette is called nozzle. While using a burette for titration, it has to be rinsed with the distilled water and then it is rinsed out twice using small volumes of solutions to be filled. Then the burette is filled with the liquid through a funnel. Make sure that the liquid is free of air bubbles before titration. During titration, hold the conical flask with your right hand and begin to turn stopcock with your left hand. The tip of the burette should be well into the mouth of conical flask so that no drops fell out during titration. While reading the burette, you should read the volume from the bottom of the meniscus at eye level. The meniscus is the curved surface at the top of the liquid level. For colored and colorless solutions, if its lower meniscus is visible for you, you have to consider the lower meniscus itself. However, for solutions like permanganate, where the lower meniscus is not visible, we use upper meniscus. Taking the difference between the initial and final volume will give the volume transferred into your receiving vessel.